Good afternoon, everyone. It's the spring of 2020 at College of the Sequoias. We are all in lockdown for the coronavirus, COVID-19. And so we've been doing videos from home. Hopefully you can see these videos and email me if you want to Zoom with me, have a video conference. I'm down to help any student. Chapter 8 is on non-right triangles. This is trigonometry. And we're doing chapter 8. This is our last chapter, I believe. Chapter 8, triangles that are non-right. Triangles that fall in this category are called oblique triangles. Oblique triangles do not have right angles in them. It falls into two categories. We have acute triangles, where all the angles are less than 90. And we have obtuse triangles. And here, one angle is greater than 90. And some of the, so we need some a little bit more terminology. We have something called congruent triangles. And what makes triangles congruent? Two triangles are congruent if the sides and angles match. Even if the triangle is oriented differently. And let me draw an example for you. So I could have, we'll call this angle A. I'm going to call this angle B. I'm going to use two lines on angle B. And angle C, I'm going to use three lines to represent the arc. The opposite side of angle A is little a. I'll use a single dash. The opposite side of angle B is little b, and I'll use two dashes. And the opposite side of C is little c, and I'm going to use three dashes. And it's kind of hard to tell the difference between small c and big C, but there it is. And then I can have a different triangle that's oriented differently. And we'll call this angle X. It gets one arc. Angle Y gets two arcs. Angle Z gets three arcs. And that makes this X, this little y, and this little z. And the quantity of arcs or slashes, so 1, 2, or 3, represent equal angles or sides. And what this last one means is like angle B is equal to angle Y. And C, side C is equal to side Z. They're the same length. When this happens, we say triangle ABDC and triangle XYZ are congruent. They're equal, just kind of one's rotated. And it's not always easy to see it visually. Rotating it, I'm sure these triangles are not equal, but pretend they are. It's hard to sketch an equal triangle. That's some background information. Let's dive down a little bit further into this rabbit hole. So often with oblique triangles, we don't have information for every side or angle. For all three sides and all three angles. Okay, but as long as we have 3 of the 6 pieces of info, we can solve for the rest. And this is some pretty good stuff. And why do I say 6? 3 sides plus 3 angles equals 6 info pieces. Now, one of them must be a side. This is vital. Why? Stop and think about it for a second. Can you tell me why? If I've got angle A, B, and C, why do I need a side? This is why. 2 triangles with identical angles can be different sizes. Or 2 triangles with different sizes can have identically 3 angles. All 3 identical angles. Here's an example. I don't even need to know what the angles are. I'll make 3 triangles. Each angle is identical to a different one of these other triangles. So I've got like angle 1 there, angle 1 there, angle 1 there, and they're all the same. Matches the angles of another triangle. But the triangles are scaled to different sizes. That's what's going on. All right. So we're going to look at several cases. We will look at several scenarios. And each scenario is different. But this information is important. In the following list, scenarios, the words are written in the order you can find them going around the triangle. And I'll draw a picture. And they're named by, they are named by the pieces of data we know. So, ready? First option we have is side angle angle. They abbreviate this SAA. Let's say I know this side, we'll call it A. That makes this angle A. And we might know angle B. So known are side A, angle B, angle A. Unknown, I will do in red. Well, we finished the triangle. This is angle C, unknown. Side C is over here, and side B is over here. So side C, side B, and angle C. So when I say we're going around the triangle, we know this side, we know this angle, we know this angle. Okay. This is a little bit different than angle side angle. In both cases, we know two angles and one side. But here we have this. We might have angle A, angle B, side C. So known are angles A and B. side C, unknown is angle C, which is over here. And we don't know B, side B or side A. So this is angle, side, angle. So those are the two examples where we know two angles in one side. Sometimes we know two sides in one angle. So let's look at those options. I can write this here though. These are the two angle, one side options. Okay. We have three more options. Two of the options, these options have two sides, one angle. Last ones, we had two angles, one side. These are two sides, one angle. We can do side, angle, side. And this one looks like an alligator. We got angle A, maybe side B and side C are known. Or we could have side, side, angle. We might know angle A or side A, side B, and angle C. And this one can cause problems. Why? Because there's a couple ways that this could have been. A, B, angle C here. Obtuse C, acute C. And this can lead to some, or they might both be acute, but it might lead to one of the angles might be obtuse. And not know it. So this generates two options, generates two triangles, or can. So those are the options for two sides, one angle. We did the option for two angles, one side. The final option is knowing all three sides. That's the third option. Side, side, side. Or SSS. This was SSA. And this was SAS. And obviously this one's simple. It can be in different shapes, they can look funny, but we know all three sides. Here, one of them is acute, or obtuse, or they could all be acute. But we have all three. Okay, so how do we solve them? The different methods we'll use, solving oblique triangles. So case one is the side angle or angle side angle case. They are effectively identical cases. With just a little bit of manipulation. Anyone know why? If we've got side angle, so little a, big B, and that makes this big C, little b, little c. How can I shift that? This is side angle. I can shift that to the ASA case. I can shift that to still know angle A. I can shift to this to knowing C and B and not knowing A. Well, not necessarily not knowing A. We still don't know side C and side B. How do we do that? Recall that the angles in a triangle add to 180. Which means angle A plus angle B plus angle C equals 180 degrees. If we know two of them, we can solve for the third by evaluating the equation. Case number two. This is the side angle. This is the rough one with the pain in the butt. Because it can lead to more than one triangle. More than one triangle or no triangles, believe it or not. Both case one and case two are solved using the law of cosines. or sorry, the law of sines. And that is what section 8.1 is on. That's what we're going to do in this one, but I want to talk about the other two cases and what they're called. Okay. Case 3 and case 4. That's our side angle side. And case 4 is when we know all 3 sides. These are solved using the law of cosines. And this is section 8.2. Okay. You are going to find, this is important, note, you are going to find that drawing a triangle is crucial. And labeling the triangle is crucial. Let's derive the law of sines. And it's pretty easy. And once you know how it comes up with, it's actually not that bad to do. And it can be done with the triangle set up 2 ways. I could have a big triangle like this. And I'm going to call this angle A, angle B, angle C. And what I'm going to do is I'm going to drop a perpendicular line right here, make that a right triangle, and we're going to call this point D. That makes this side over here little side A. That makes this whole side over here little side B. And that makes this little side C. We'll call this vertical distance here in the middle H. This is the acute option. Now we have the obtuse option. So let's make angle A obtuse. So here's point A or angle A, point B, and point C, which makes this little a, little b, little c. What we're going to do is we're going to extend this line further, bring this line down into a perpendicular angle. We'll call this point D over here. And now this is a vertical height H. So what I'm going to do is I'm going to break I'm going to call, since in this one, I'm going to chop this up. This is B1 and this is B2. Okay. So B equals angle B1 plus angle B2. And now let's look at our 2 triangles. I have triangle, we have triangle, and I can do that over here. Let's see which one goes with B1 goes with AC ABD. And we'll call that B2. So in both cases, angle B equals angle B1 plus angle B2. We have in triangle A, ABD, or AB1D. Let's look at that one. What's the sign of A? It's opposite over adjacent, right? Does it matter which triangle I look at? This is angle A. The opposite of A is little h. The adjacent of A is little c. And I can do that over here. Opposite of A is h. The adjacent side is c. Sorry, I don't want to look at A there. I want to look at C here. Look at C. This tells me, if I clear the fractions, H equals C sine A. Now we'll look at the other triangle. Let's look at triangle B2, CD. And what's the sign of C equal? Let's just focus on this triangle right now. This one's the easiest one to see. The opposite of C is H. What's the adjacent? I'm saying that funny. It's not opposite over, that's what I'm saying wrong. It's not opposite over adjacent, it's opposite over hypotenuse. That's what's wrong. Fail. That was a fail. All right, you get a little ahead of yourself. All right, so sine of A, opposite over hypotenuse. Sine of C, opposite over hypotenuse. Hypotenuse is A. So here, H equals A sine C. And I can do this in this triangle as well. These H's are equal. It's the same H because it's the same side, just of two different triangles. So we set those equal to each other. C sine A equals A sine C. And now get the letters together by dividing through by the sides. Divide both sides by AC. And I get sine A over A equals sine C over C. Pause and work that through. Make sure you get that. Opposite over hypotenuse. We set these equal to each other. And then we're going to solve. The C's cancel there. The A's cancel here. And you're going to find, if you do that with angle, throw angle B in there. We can break it up the other way. You're going to see sine of A over A equals sine of B over B equals sine of C over C. This is the law of sines. Named such because it only has sines in it. This also works with the reciprocal. We can also have, if we just flip everything over, A over sine A equals B over sine B equals C over sine C. Also law of sines. And choose the one where your variable is not in the denominator. And if we put this in normal words, the lengths of the sides of a triangle are proportional to the sines of their opposite angle. And like on the triangle, angle A is on the opposite side of the triangle from side A. So pro tip number one was this. This is pro tip number one. Pro tip number two. Use given values over calculated or rounded values. Because anytime you're using a calculator, you're almost always rounding it until the end. This minimizes rounding errors. Okay. Something I learned in going to applied mathematics, they drove that home. Because when you do it in applied mathematics, usually the computer's doing it, and the computer's frequently rounding it. So you want to write the code so it's rounding as rarely as possible, because it's really easy for the errors to start compounding, and pretty soon what was a nanometer becomes a meter. And if you're looking at like NASA launching something towards Mars, that angle that we launch at, even if it's off by 1/1000th of a degree, Mars is so far away by the time it gets there, that could be a huge difference in distance. Okay, so minimize those errors, wait till the end around, and we'll do that when we're working in here. Let's look at some examples. So we'll do a side angle. Side, so what do we know? Angle A is 37 degrees. We're going to say angle B is 79.4 degrees. And side A is 12.6 centimeters. So I'm going to draw a triangle. So let's call this ABC. That makes this ABC. And I'm going to label what I know. This is 37 degrees. This is 79.4 degrees. And side A is 12.6 centimeters. Sometimes it helps to make a little table. Angle A, angle B, angle C, side A, side B, side C. Fill in what you know right away, and that way you can see what you're looking for. Okay, so what are the things we can find right now? Without having any information on side C or angle C, we can't do anything with it until we get it. Our options are we can use the law of sines to find side B, or we can just find angle C by using the fact that they add up to 180. That one's probably easiest first. Angle A plus angle B plus angle C equal 180. 37 degrees plus 79.4 degrees plus angle C equals 180 degrees, which means angle C equals 180 minus 37 minus 79.4 degrees. (63.6 degrees). I'm going to fill that in a different color. Sometimes I think making sure you keep track of what's given and what you solve for is helpful. All right, now let's solve for our sides B and C. Another way to avoid errors and this is what I meant earlier, use given values first. This is good. It's unavoidable in the first part. Let's find side B. I want B to be in the numerator. So I'm going to have A over sine A equals B over sine B. This is given, given, given. Okay. I've got 12.6 centimeters over sine of 37 degrees equals B over sine of 79.4 degrees. So if I solve for B, I multiply both sides by sine of 79.4. B has to equal 12.6 centimeters times sine of 79.4 divided by sine of 37. I'm going to do this all in the calculator, all in one step. 12.6 times, am I in degree mode? I don't know that I'm in degree mode. Let me check. Mode 1. There we go. Now I'm in degree mode. Just had to make sure. So 12.6 times sine of 79.4 divided by sine of 37. So the calculator spits out 20.579388889. Looks like that's repeating. I'm going to use the number of decimal places that side A had. Be consistent with side A. Which had 3 significant digits. So I'm going to look at those, check that one. We're going to round to 20.6 centimeters. Okay. Now to find C, finding C. I've got 2 options. A over sine A equals C over sine C, or B over sine B equals C over sine C. Those are my 2 options. Okay. Let me do this. That way we have our data down here. So let me rewrite that. A over sine A equals C over sine C, or B over sine B equals C over sine C. In equation A, the first one, this one's given, this one's given, this one's calculated. In this one's given, this one's calculated, this one's calculated. Not only is this one calculated, B was rounded. If I use this one, I already have a rounding error in it. Because I rounded 20.6, didn't I? 20.6, I still got it in the calculator, was 20.579388889. So I might as well just go with this one. Let's use this one. Let's fill in what we had. A was 12.6 centimeters over sine of 37 degrees equals C over sine. And there's no way of avoiding it. We got to use the angle C that we calculated. So we solve for C. C equals 12.6 centimeters times sine of 63.6 degrees over sine of 37 degrees. C equals 18.75321776. We're going to look at 3 decimal places or 3 significant figures. I check the one to the right. It says round up. So C is going to be 18.8 centimeters. And if I were to do it like on my test, I'd go back and put it in right here. What does that accomplish? Let me leave room for that to finish writing that. What does this table do for me? It does a couple things. The table helps me organize what I know and don't know. That's the first thing it does. Guess what else it does? And it puts all the answers in one spot. This is good for a couple reasons. You're not searching the page for missing data. And guess who else isn't? Neither is your teacher. You get all your values organized, they're in one spot. If I see that they're the right answer, I'm just skimming to make sure what you wrote down in your steps looks like what it should. Like I'm scanning it. I'm not having to comb through it for fine detail. Look for your answers. You put them all in one spot. All right. Ready for another? Okay. Example 2, this will be an angle side angle. And am I pulling it from here? I think I am. I buried it. Yeah, I changed it up a little bit. I'm going to put the law of sines back up. That's nice to have it in one spot. All right, so angle side angle, let's make our box. We'll just talk about what we have. I'll put our given information this way. Our given information, we know that angle A is 28.40 degrees. We know side B is 290.2 feet. And we know side C is 105.60 degrees. And let's say this is 290.20. You know what? I'm going to say this is 28.400. That way we have 5 significant digits everywhere. You don't always have that. You're going to use what you're given, your measured amounts. What do I have here? I have angle C is pretty big. So if I'm going to draw a triangle, I'm going to make angle C. C is bigger than 90, right? This is going to be an obtuse triangle. So that'll be C. We'll call that A and B. So this is 105.60. This is 28.400 degrees. And we know side B is 290.20 feet. What are we looking for? We're looking for angle B, side C, and side A. Why don't you guys go ahead and try this real quick? I'll pause the video. I recommend finding angle B first, then calculating side A and side C. I'll assume you pause the video and we'll get started. So let's find B first. Angle B plus 28.4000 or 00 degrees plus 105.60 degrees. That's angle A, and angle C equals 180. .000 degrees. So let's find A and C. So A, I gotta use side B and sine B in both. So I've got A over sine A equals B over sine B. A over sine of 28.4 degrees equals B, which is 290.20 feet, over sine of B, which is sine of 46 degrees. I'm just going to go back to as little numbers as I can for now because it's easy to write. I'll put my solution in 5 digits. A equals 290.2 times sine of 28.4 degrees over sine of 46 degrees. Times sine of 28.4 divided by sine of 46. Five decimal or 5 digits, 191.88. I'll use B again for C because that was the easiest. That's the one that doesn't have any rounding in it. 46.000 was not rounded. .290.2 times sine of 105.6 divided by sine of 46 equals, what I got there, C equals 388.5643152. And we look at 5 significant digits. C equals 388.56, and the sides were in feet. Okay, those are the 2 examples for the easy case in law of sines. Let's look at our problem child, side-side angle. So the problem child is side-side angle. We can have 0, 1, or 2 triangles as solutions. So let's just say we're given so we'll call this angle A. That makes this down here angle B. And we'll call that C. And we know side B and side A. Okay, so what you got to start off doing, okay, if we look at the table, what do we have? Kind of helps tune down what we need. So we're given angle A, and we're given side A and side B. It looks like we got to start here. Start with law of sines to find angle B. Now this ends up resulting in 2 options, or 3 options. So option 1, outcome 1. The sine of B is greater than 1. What does that tell us? What do we know about sine? The sine of any angle is always between -1 and 1. If sine of B is greater than 1, we're outside the range of sine. There's no solution here. Outcome 2. Sine of B equals 1. What does that tell us? When does the sine of B equal 1? B has to equal 90 degrees. That's the only time sine of B equals 1. So this is a right triangle. And it means the other 2 angles are less than 90. There's only one triangle, or one solution. Finally, outcome 3. We did sine of B is greater than 1, sine of B equals 1, sine of B is less than 1. This leads to one or two triangles. So let's just say it's like equals K. So since there's two triangles, let's maybe label them B1 and B2 for the second triangle. If there's a second triangle, it'll have a different angle. I'll pause, let you finish writing that. Okay. So let's look at it. The sine of we'll call it sine of B1. It equals K and it's less than 1. This tells us B1 equals sine inverse of K, right? Then calculate B2. That's got to be the supplementary angle. Okay, now, if this is the criteria, if angle A and we add it to angle B2, if that's less than 180 degrees, there's a second triangle. Okay. And the way this one differs than previously, here we have two sides given, not two angles. And that's where the problem lies. So we're going to calculate angle B. Or calculate B1 using law of sines. This helps us decide whether it's 0, 1, or 2. Sine of B1 is greater than 0 or greater than 1. 0 triangles. It equals 1. There's one right triangle. And if sine of B1 is less than 1, that required more steps. Calculate B2. And then check if A plus B2 is less than 180 degrees. If so, there's a second triangle. All right. Are you guys ready to do some examples? Let's do it. Let's do it. This is the good stuff. This is what we're waiting for. Why do the easy stuff? Go for the challenge. Challenge that makes us great, makes us shine. So, example. Let's make our table. I've got angle A, angle B, angle C, A, B, C. What I'm given, angle A equals 55.5 degrees. Side A is 8.94 meters, and B is 25.1 meters. This makes this our angle of question. So I'll call that angle B1, and we might have an angle B2 and a side B2. Maybe. So let's find sine of B1 first. We have sine A over A equals sine B over B. Sine of 55.5 degrees over 8.94 meters equals sine of B1 over 25.1 meters. So sine of B1, we solve for that by multiplying by 25.1. I've got 25.1 meters over 8.94 meters times sine of 55.55 degrees. Notice the meters cancel out. So the only units here are degrees. What does sine of B1 equal? 25.1 divided by 8.94 times sine of 55.5. Sine of B1 equals 2.314. That's greater than 1. There's no solution or triangle. Okay. Let's do the next one. Again, given is in red. We're given 55.3 degrees. A is 22.8 feet. B is 24.9 feet. Let's find sine of B. We'll call it B1. Sine of B1 over B equals sine of A over its side. That's sine of 55.3 degrees. What do we get? Eight, 9, 7, 8, 6, 7, 8, 3, 4. So use the inverse. I'm going to say sine inverse of answer. I get 63.87920.366. We'll keep it to 3 figures. 63.9 degrees. Okay. Before I calculate C, I'm going to check for B2. And then we're going to do A plus B2 equals 55.3 plus 116.1. This is 171.4 degrees, which is less than 180 degrees. There are going to be 2 triangles. So maybe I'll set up another box over here. I'll set it up on the next page where we're going to calculate it. Second triangle. Which means there's an angle or angle C2. A is still 55.3 degrees. A is 22.8 feet. This was 24.9 feet. And I just calculated this as 116.1 degrees. So I'm going to come back to that one. Let's come over here and finish this triangle. I'll leave that up there so you can still look at it and finish writing that if you need to. So we've got a B1, little b1. Well, B, little b, side B doesn't change. Angle C1 and side C1 change though. So C1, well, it's 180 minus 55.3 degrees minus 63.9 degrees. I'm going to make that in blue because that was a rounded error, a rounded answer. So what is that, 60.8 degrees? And now we'll do C1 over sine of C1 equals, I'm going to use A. C1 is 22.8 feet times sine of 60.8 over sine of 55.3. So C1 equals 24.20819.512 to 3 decimal places or 3 figures, 24.2 feet. That's just our first triangle. Now let's go on to our second triangle. So C2 is going to be 180 minus 55.3 degrees minus 116.1 degrees. And if you calculate that, you get 8.6 degrees, which is a very small angle. And then we do A over sine A equals C2 over sinus E2, 22.8 over sine of 55.3. Notice I'm always going back to where I use as many pieces of given information as I can. I solve for C2 by clearing the fraction. And we want 3 significant digits. So 4.15 feet. All right, ready for another one? That's my dog. I don't know if you can hear him. He's a siren. All right, he stopped. Now I can do the next example. I guess my wife's pissing off the dog. We're going to have angle A equals, take our table. We've got 43.5 degrees, 10.7 inches, 7.2 inches. And why don't you guys work that one out? Show me what you got. What one do you have to calculate first? That's a good starting point. Looks like you got to start with angle C, right? Okay. I hope you paused it, worked through it. So we're looking for angle C. We're going to do sine C over C equals, we're going to use A, sine A over A. Let's call that 7.20 inches. Let's make sure we got 3 digits on everything. We solve for sine C. We call that K. So C equals sine inverse of K. (27.6°). Let's calculate C2 real quick. That was C1. C2 equals 180 minus C1, which is 180 minus 27.6°. Is that 152.4? So this is a quick check. Now we're going to do A plus C2. That adds up to 195.9°, which is greater than 180°. So there's only one triangle. So now we'll just find B and angle B and side B. And that's 108.9°. And then we've got B over sine B. (108.9) equals A over sine A. The 3 decimal place or 3 digits, 14.7, and that's in terms of inches. Okay. Now, there is another type of problem they use this in. Do you remember the area of a triangle? I think the book likes to call it SA. I'm going to call it a triangle, like that. It's 1/2 base times height. But that's my base. The height is this vertical distance. If we drop a parallel line, that's H. For most triangles, H is not given, but it is calculatable. Let's go back to how we derived the law of sines. How did we derive the law of sines? We had H equals C sine A, and we had H equals A sine C. So what's the area become if that's A? H. It's 1/2. I can do B times C sine A. I can do 1/2 B times A sine C. And if we made the H go in that way, you can effectively write this as 1/2 AC sine B. I think the easiest way to remember this area of the triangle equals 1/2 two sides multiplied times the angle of the third side. Or this angle letter, that's the angle letter, and we've got two side letters. The angle letter is different than the two side letters. It's all just, whichever one you choose here is all about how you orient them. I'm going to get rid of that one right there because it looks sloppy. Now you can see all three where they're not looking ugly. Give you an example. Find the area of the following triangle. This is going to be 24 degrees, 40 minutes, 52 degrees, 40 minutes. This will be 27.3 centimeters. And that makes this side C and side A. So what pieces of information do we have? This is an angle side angle. So let's find angle B first. We'll subtract the other two angles. This might be easier. I'm going to take 2 of these degrees and convert them into minutes. So I'll have 120 minutes. So I've got 178 degrees minus 24 degrees minus 52 degrees plus 120 minutes minus 40 minutes minus 40 minutes. This 120 is positive. Remember, 1 degree equals 60 minutes. $178 minus 24 minus 52. 102 degrees. 120 minus 40 is 40. So that's angle B. So what was our formulas? We had, let's just see where we're heading. Is we had 1/2, we can do AB sine C or AC sine B or BC sine A. It looks like I need one more side, right? I need one more side. Doesn't matter which one I go for. Let's go for C. Oh, screw it. Let's go for A. So when you're doing it, that 24 degrees, 40 minutes is 24 degrees plus 40 divided by 60 degrees. Which is 24.6 repeating. Same on bottom. (27.3 centimeters) times sine parentheses of 24 plus 4 divided by 6. Did I have a multiplication sign in there? Yes, I do. And then we're going to divide it by sine parentheses of 102 plus 4 divided by 6, or 40 divided by 60. What do I get there? I get 11.67754462. So let's do triangle A, or area of triangle, area of the triangle. I don't want to round here until the end. That 11.67754462 times B is 27.3 times sine of C, 52 degrees, 40 minutes. Crap. Times 27.3 divided by 2 times sine of 52 degrees plus 40 over 60 minutes. And this is area. We were working with centimeters. This is squared centimeters. We'll go to 3 decimal places or 3 significant figures. That's what my slide had, 27.3. This is about 127 centimeters squared. If you look in the old lecture notes, I solved for side C. And I got C to be 22.2 centimeters. And then A triangle equaled 1/2 BC sine A. And that again ended up being approximately 127 centimeters squared. So it doesn't really matter which one you went with, as long as you were precise with it. And that will wrap up 8.1. And I'll get this uploaded soon. I'm going to try to get 8.2 done tonight. Peace.